We present Hapt-Aids, self-powered, on-body haptics for activity monitoring. We envision our bandage-like devices occupying a useful middle ground between two existing and successful technologies. At one end of the spectrum, consider the example of fitness trackers, powerful and multi-purpose computers, but expensive, sometimes cognitively demanding, and require frequent removal and recharging. At the other end of the spectrum, we have the simple Band-Aid, effective, robust, and inexpensive, but also single-purpose. Once applied, users can forget about them. Hapt-Aids retain the low-cost, stick-and-forget nature of Band-Aids, but gain sensing and output capabilities that allow them to react to user activities. Consider a Hapt-Aid that tracks a user's sun exposure using a solar cell, which also powers our board. Over time, our system charges a capacitor, which both stores power for later use and also represents the state of the user. Using a basic voltage trigger, corresponding to a maximum sun exposure threshold, the board will dump its stored energy into a haptic actuator, notifying the user that they have reached their recommended limit. Activity-specific energy harvesters act as a power source and sensor, avoiding the need for batteries and compute. Our circuit design is fully analog, keeping cost and complexity low. Our boards are tunable to support different use cases. First, the choice of capacitor will affect charging time, as well as the strength and duration of the haptic notification. The inline resistance from the energy harvesting chip to the capacitor tunes the charging rate. A trigger voltage sets when the capacitor is discharged. Adjustable leakage current from the capacitor supports applications that lose state over time. For instance, in our sun exposure example, the stored solar energy will reset overnight. We also include a manual reset button to instantly discharge the capacitor. And finally, the choice of haptic actuator also varies the haptic strength, duration, and frequency of activation. Our modular and tunable design supports many end uses. We built 5 into functional demos. As already discussed, we built a Hapt-Aid for sun exposure, allowing users to have fun outside and be notified after they've passed the daily recommended limit. We also created a step-counting Hapt-Aid using an electromagnetic clicker. Users are alerted haptically when achieving their mobility goal for the day. We can also harness energy from rotary motion using a DC motor. This generates energy as users bend their elbows and can be used for counting reps in weightlifting exercises. We also built a Hapt-Aid with a shaking electromagnetic coil. Energy is generated whenever the coil is jostled, so this device can be used for any movement tracking, like during sit-ups. As an additional exploration area, Hapt-Aids can harness active energy from wireless transmitters placed in the environment. This broadens the scope of our technology to include activities that may not produce enough energy on their own to trigger haptic feedback. With additional engineering, we believe Hapt-Aids could be similar in size and cost to mass-produced RFID tags, which cost roughly the same as Band-Aids today. Please refer to our paper for more details.